In this presentation, I'm going to present DoggyDuty, an Android graph visualization library. My name is Zachary Hughes. So if you remember, the whole goal of this was to be able to clean up my dog's waste more efficiently. Basically, every time my dog goes to the bathroom outside, I wanted to use Android to place a marker on a Google map, and then later to be able to visit all of these markers in the most efficient manner possible. Okay, here is the user interface of my application. As you see, you have a record button to drop a marker at your current location. You have a remove button, which removes all of the markers currently on the map. And then you have a shortest path button. Basically, the shortest path button will compute the shortest path according to one of the three algorithms in the radio buttons below it. Initially, I believe that Dijkstra's algorithm and A-star pathfinding and shortest path algorithms would be able to give me the traversal needed to visit all of the nodes in the shortest manner possible. But after implementing them, I quickly came to understand that I misunderstood the problem, and that the problem was the traveling salesman problem, where you visit every node in the graph and then return to the starting location. So as you see here, this is what happens after you record a marker and then you record another one. So it just takes your current location and drops a marker. This is what it looks like once the user plots many vertices. So at this point, I want to find the shortest path. So what I would do is click this traveling salesman or one of the algorithms. I click traveling salesman, and then I click shortest path. And then this is what the application would show you at that point. After clicking remove, all of the markers would be then deleted. So the libraries I used were Google Maps to draw a Google Map instance, drop markers, visualize those markers, and then draw polylines, or the lines connecting the vertices. I also use Google Play Services location to retrieve current location data. And then I used Volley and Google Map directions to get turn-by-turn directions. Basically, Volley is an HTTP networking helper library that allows you to easily create HTTP requests. I then used Google's JSON library to serialize the JSON and deserialize it. I also needed to create a custom Java class so that my Google Maps directions could be transformed from JSON to a usable Java object. Lastly, I used SQLite. SQLite was used to store coordinate data for later use in a table. Once you click remove, all of those coordinates are then deleted from that table. And that is my application. Thank you very much.